Okay, here's what we're going to do. We are going to go over the review. First thing I want you to do, if you picked up one of the reviews yesterday, then you're going to need to do something very important, and that is go to the back page, rip it off. Let's see here. Hold on. No, wait. If you got it yesterday, if you have 21 through whatever on your review, rip it off. We don't need it. Yes, I am recording, Abby. All right. This is for all the kids that or the students that were out today that wanted to get this review. I'm going to try to post this online so that people can actually get to it, or post something for people to get to, whatever, so they can see the review if they need to. All right. We're going to have to go through this rather quickly for time's sake. We are also going to eliminate certain problems. So if you want to go through your review as I do right now, and I want you to go to the second page, number 7. Number 7? Goodbye. All right, we're going to go on to number, let's see here, number 15. Oh, nice knowing you. Okay, number 16. You were too close to 15. Okay, and then let's see here, 18. Oh, 18. Yeah, we don't like you either. Okay, and I think we keep the rest of them. Okay. Now, one more thing on the test, you can use a 3 by 5 note card on the test with your sine, cosine, tangent, all the laws and area laws and rules and so on and so forth. So you can use that for the test. The test is tomorrow, April the 14th on Thursday. So make sure that you're ready for the test tomorrow. Also on the actual test, I did something very nice for you guys. Separated out, the first couple of questions are over 9, 1, 2, and 3. Doing the proportions, Pythagorean theorem, so on and so forth. There's no trigonometric ratios or terminology used for the first couple problems. And then there's a big notice that says, okay, from here on you're going to use those. So you don't have to get confused as to what you need to use on those problems. All right, so in the beginning here, this review is not set up that way, so we're going to kind of jump around back and forth. But it should go pretty good, pretty smooth for us today. Okay, we have got. I'm gonna zoom in a little bit. Zoom in a little bit here, and actually, I think it'll work okay. Let's turn off the lights here, Smith, and open these blinds, please. Okay, I think this will work. Okay, so number 1, it says, determine whether segments, and it's just autofocusing, don't panic people on the computers. Determine whether segments with lengths 29, 19, and 29 form a triangle. So we have to do our triangle check first, and then we classify the triangle as acute, right, or obtuse. Okay, so first thing we do is we take the longest side. Which one's the longest side? Oh, wait a second. We've got 2 that are the same size, and they're both the longest. So what does that tell us about this triangle first? It's an isosceles, right? It's got 2 of the sides that are the same. And just visually, if I look at this, I need to make sure that these 2 are bigger than that. Well, if this is 29 and that's 29, isn't 29 plus 19 going to be bigger than 29? Yeah, okay. So this definitely does form a triangle. So that's good. And then, again, visually, if I look at this, I've got these long legs, kind of like a stork. And then I've got this little 19 leg down here, or side. This is 29, that's 29. What kind of triangle is this going to be? Acute. We don't even have to apply our rules. This is going to be C. But our rule would be if 29 squared plus 19 squared, which are the 2 smaller, even though one of these is already, or is the same as, sorry, is the same as the other one. If this is smaller than that, then it's acute. If this was larger than that, it would be obtuse, and if they're equal to each other, it would be a right triangle. Well, we already established that these 2 are longer than this one, so 29 squared plus 19 squared is going to be bigger than 29 squared, right? In fact, it's going to be 19 squared bigger than that. So this definitely is smaller, which gives us the acute definition for the triangle. All right, number 2, find the values of the variables. If necessary, round decimal answers to the nearest tenth. Right here, we're going to use, what do you think? We've got leg lengths of a right triangle, but we don't have the hypotenuse, right? This is the hypotenuse. Don't ever forget to label it and note which one is which there. Which trigonometric ratio deals with the legs, not the hypotenuse? Yeah, I'm hearing multiple answers, but tangent is the correct one. Tangent of what angle here? The one that we know, right? 35 degrees. Tangent of this angle is going to be opposite over adjacent, right? And so opposite over adjacent is going to be 4 over x. So tan 35 degrees is going to be 4 over x. We'll cross multiply. So x tan 35 is going to equal 4. And we're going to need to get x by itself, so we divide the tan 35 out. Tan 35. So x is going to equal 4 divided by tangent of 35. Okay? And if you put that in your calculator, which we know how to do, I don't know how well this is going to show up on this screen because it's going to be a little bit bright, but I'll turn it as we need to. 4, let's see here, 4 divided by tan of 35 should give us 5.71, and we round to the nearest tenth to be 5.7. So approximately 5.7. D should be your answer here for number 2. All right, number 3, moving along rather quickly. Again, we've got a lot to cover in a short amount of time here. We need to find x and y. Let's set them up without solving them first, just so we can kind of make sure we know how to set up one or the other. I have a hypotenuse, but the only known is this leg right here, which is my adjacent, right? And we need to have another unknown, which is going to be opposite of the known angle, we'll say, right? So this can be the known angle is 33. Opposite of that is going to be x. Adjacent to it, 7. The hypotenuse is going to be your y. Now, first thing we can do is we could use tangent again to find x, just like we did in the previous problem. So we could say tangent of 33 is going to be equal to x over 7. We could cross multiply, and x is going to be 7 times tan of 33 degrees. Now, like I said, let's set the other one up too, just so we can make sure we know how to do these. Because if you found x in this case, there's only one x that has the right answer, and obviously they're all different, so you would find the answer pretty quickly. But the y value, we'd want to set it up as cosine of 33, because cosine deals with adjacent and the hypotenuse. So we would say cosine of 33 degrees is going to be adjacent over hypotenuse, 7 over y. And so then we would cross multiply again. Y times cosine 33 is going to be 7. We need to get y by itself, so we divide the cosine 33 out. So y is going to equal 7 over cos 33. Now, in both of these cases, we're going to end up with the answer C, because x will equal 4.5, approximately, and y is going to be approximately 8.3. Okay, so C will be your answer on this. All right, so number 4. This is pretty easy, right? Sine 33 in terms of cosine. All right, sine in terms of cosine. And we said in our notes and stuff that this was real simple. We just needed to find the complement of 33, and sine of one angle is cosine of its complement. Well, complement, let's write that down. Complementary angles is what we're kind of dealing with here. So what is the complement of 33? What plus 33 equals 90? 90 minus 33 should be 57, yeah. So cosine 57 would be the same thing as sine 33. And of course you could put that in your calculator and confirm that, and that would be an easy way to double check this answer. Okay, well, let's flip the page. And on number 5, we're going to solve for the triangle, or solve the triangle, which means we're going to find the angles and the sides. Alright, so we're going to look at this triangle, and they're going to give it away pretty quick. we're going to give it away pretty quick by saying, well, the angles are all 31. So we know that that has to be 31. And then what we're going to do is we're going to try to find the missing side lengths, which is going to be pretty easy. We've got the hypotenuse, and again, let's label the hypotenuse. We know it's across from the 90-degree angle, so that's going to be real easy when we start setting up our ratios on this. All right, and then we can do anything you want to right here. We got all kinds of options, but one of which would be, do you want to use cosine or sine? Sine, cosine, sine, sine. Okay, they want to use sine. All right, so if we're using sine, then sine of, start with 31 degrees is going to be what over what? Sine is opposite over hypotenuse. So it's x over 11. Now, when I find y, I need to do sine of 59 degrees, and that'll give me y over the hypotenuse. Right? And I just need to solve for these. Cross multiplying, x is going to equal 11 times sine of 31. Cross multiplying, y is going to equal 11 times sine 59. And in both cases, we're going to end up with x equal to 9.4 and y equal to 5.7. A will be our answer on this one. If you put those in the calculator, and we can do that real quick if you want to. 11 times sine of 31 gives us 5.7. Oh, sine is x over 11. Did I do the wrong one here? Should be, hold on, which one is this one? This one should be D. I'm sorry, yes. I had them flip-flopped. Sorry, not A, D. Should had them flip-flopped. This should be 5.7 approximately, and then y is going to equal or approximately be 9.4. Sorry, flip-flop those. Okay, number 6. Oh, on this case here, by the way, we solved all 3 angles, and then by solving those 2, we solved all 3 sides. So we solved the triangle itself. Okay, number 6, let's move on to that one. On number 6, we've got a situation where we need to solve the angles and the sides, but they only give us one. It's not a right triangle, so we can't use Pythagorean theorem for the third one. Not quite yet. We can use our little ratio of angle and corresponding side length, like this would be little b, this side would be little c, and that side would be little a. And we can say, well, we know the sine of one angle over its corresponding side length is the same thing as the sine of another angle over its side length. Well, we know b, but can we find a, angle A? We can do that if we go sine of 70 over 24 equal to sine of A. We don't know what A is, but A's side length is 14. And in this scenario, we only have one unknown. Everything else is known, so we can solve for the unknown in this case. All right, now this is a little bit tricky at first because you're going to have to use the inverse in a minute, but it's not too bad. We'll cross multiply to get to our next step, which is going to give us 24 times sine A equal to 14 times sine of 70 degrees, right? Then I'm going to divide out my 24, divide out 24, and I'll have sine A equal to 14 times sine of 70 degrees all over 24. Now, you'll remember that in our practice I said, it might be a little simpler if we go ahead and get us a number in the calculator for this right here. So if we go ahead and put that in the calculator, we're going to have 14 times sine of 70. We'll find out what that is, divide it by 24, and we have this nice little number here that's just a decimal with a whole bunch of decimal places that we don't really have to write down and remember because we use our next little trick. When we need to find sine of an angle equal to some value, well, that's the same thing as saying the measure of the angle is equal to inverse sine of whatever that is. In this case, it's 0.548, blah, 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 blah. So in the calculator, we will do this. we will do inverse sine, basically. Second sine gives us inverse sine. Okay? Everybody can see that on the screen. And I'm going to arrow up and grab that value, hit enter. It throws it into my sine inverse, so you can see that, and I'll hit enter, and it gives me a value of 33.2. Okay, so my angle measurement for A is 33.2 degrees. 33.2 degrees. When I subtract these two from 180, this angle will be 76.8. Okay? And so now we have all the angle measurements. We need the last side. We found A, or A is already 14, sorry. So we have 14, we have 24, we have this angle, that angle, that angle. We just need the last side length. This will be simple because we can start with the same known that we had before. Sine of 70 over 24 is going to equal sine of C, 76.8, over little c, the side length. We don't know what it is, but we can find it by using this ratio. All right, we'll cross multiply, and this is going to be nice because we don't have to do any inverse sine stuff. We're just going to do some multiplication and division. When we cross multiply, c times sine of 70 is going to equal 24 times sine of 76.8. Okay? And then we'll divide out the sine 70 from both sides. That becomes a 1. C is going to equal all of this. We'll put that in the calculator. 24 times sine of 76.8 divided by sine of 70. Doing it in 2 steps to make sure I don't mess up parentheses or anything else in order of operations. I should get 24.9 in this case if we round it up. 24.9. So I have the angle measurement, side length, and we have our other angle measurement there. So I solved the triangle. Okay, moving right along. And of course, if you're watching the video, you can pause at any time if you need to keep up with the notes. On number 8 and 9, probably the hardest 2 questions on the entire test. All right, so you're going to need everybody grab a calculator and follow along. Now, again, if you've got a iPhone, and most phones, smartphones have a calculator app. If you got the iPhone, you just turn your calculator on, turn your phone sideways, it gives you the full scientific notation. I can demonstrate that here on my phone. If I go to my calculator app, and I'm like this, if I turn sideways, you'll notice it gives me all of that. You can see it there, I think, if I do it like this. So it gives you all the operations that you need to have. I'm pretty sure you should be able to do it. 1 over x is kind of like your inverse, and the second may be the options, you know, to do the other functions. But so if you don't have this scientific calculator, you can do this at home. You should still be able to do these 2 problems. Again, probably the hardest ones on the test. Cosine of 145, hit enter, and the answer is negative 0.8191, actually 92. So that answer is D. That was pretty hard, wasn't it? Do we need me to go over that again? Okay, here we'll practice it on number 9 because that's a tough one to do and to kind of digest there. Okay, but here we go. Sine of 152. Now here's where you can mess up real easily. If you don't punch in the buttons just right, it'll give you the wrong answer. Okay, so you're going to have to make sure you punch in the buttons just right here. Sine of 152, because if you put 125, it's going to come up different. But okay, here we go. We hit enter, and it gives us 0.4694, which will round up to a 5, so that should be B. And I'm so glad we got through those 2 problems because now the rest of it's a breeze. Okay. Those are some gimme questions if you haven't noticed for your test. But nonetheless, if you don't know how to use a calculator, then you could get those wrong very easily. So, all right, number 10, find the area of the triangle, round your answer to the nearest tenth. Now, we don't have a height for this triangle. No way to really tell what that height length would be. But we can use one of our little rules about area, and that is the area of a triangle is equal to half B times C times the sine of A. In this case, A's here, there's B, and here's C. Alright, and so I can say 1/2, area is going to equal 1/2 of B times C times the sine of 25. Okay? And if I put that in my calculator, then I should come up with 234.6, whatever units they are, centimeters, millimeters, inches, yards, feet, whatever, squared. Units squared should be my answer there. 234.6 units squared. Okay, and again, that's just the formula that you should write down on your index card for the area using the sine rule there, sine law. Okay, you plan to install a sprinkler on number 11, and this is kind of a good question. I like this question. It's kind of neat, makes you think. Install a sprinkler system in your yard. You designate one sprinkler head to lie on a vertex of a triangular garden. Okay, and here's the dimensions of the triangular garden. You're going to have 34, 19, 34, 19, and 43. Okay, the sprinkler heads are ordered according to the angle which they rotate. Which is the largest? We're looking for the largest angular rotation you can order. In other words, if I put a sprinkler head at these locations, which one has to rotate the most to cover the more area of the garden based on the angle that it has here? Well, let's label these. That's A, B, and C. Isn't A going to be the largest angle in this triangle? Isn't it the one that has to rotate the most, right? Because this has the biggest angle. And so the one across from 43, the largest side, is going to be the largest angle. And what it's asking us to find is the angle itself. What is that angle? What is the angle A? And we don't have, any other rules or formulas that we know except for law of cosine. And that is that if we have A, B, and C, on this triangle, we know the side lengths, and we're trying to find an angle, we can do that. We can say this side length that the angle that we're trying to find, we take that side length, we square it, and that's going to be equal to B squared plus C squared minus 2 times B times C times the cosine of A, the angle corresponding to the side that we started with. Okay, again, this is another rule that you'll need to write down on your index cards. So let's plug in some values. A is 43, so 43 squared plus B squared, which is 34, equals B squared plus C squared minus 2 times 34 times 19 times the cosine of A. Now, again, we've got an equation here set up where there's only one unknown, and that's the angle itself. We can solve this because we know everything else. Right. Now, the numbers get kind of large, and, for sake of time, I'll just kind of plug these in for you. 43 squared is going to be 1849. 34 squared plus 19 squared is going to be 1517. 2 times 34 times 19 is going to be 1292, and that's going to be times cosine A. All right, now we'll subtract 1517 from both sides because, again, we're trying to get this by itself. So we'll subtract first. Take 1517 from both sides. That will become a 0. This side will be 332. Then we're going to have a negative 1292 cosine A, and we'll obviously divide out negative 1292 from both sides. Okay, move this up for more room here. When we do that, that becomes a 1, leaving us cosine A. And this will be equal to, actually it's going to be like a negative 0.25696, and blow on, blah, 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 just keeps on going forever. Okay, now, when we put this in our calculator, and I'll do that, let's put that in there. We're going to take 332 divided by a negative 1292. We get this number, this negative 2.25696594443, and so on and so forth. We know, according to our practices from before, cosine of an angle equal to x, some value, actually tells us that the measure of the angle A is actually cosine inverse of x, or whatever this number is. Right? We talked about kind of the concept if you were dividing cosine out of that angle. And then cosine, 1 over cosine is like cosine inverse, right? So that's cosine inverse of this times that. So negative 0.25696, so on and so forth. So if I did second cosine on my calculator, so cosine inverse, and I arrowed up to grab that number and hit enter, I'm going to end up with 104.8 or 105 degrees. And that is your answer D. That's the largest degree that we have there. So just using the law of cosine, we can find that measurement. Okay, on to the next page, number 12. Number 12. This is a little bit tricky. This is naming the similar triangles, and we had a little trouble with this on our quiz because we would get things out of order. Okay, when there's an angle, that you're dealing with, you need to keep that angle in the right order every time if possible. And then if you're talking about right angles, you obviously want to keep corresponding sizes of angles with corresponding sizes of angles of the two triangles that are similar. So in the first one, it does put the right angle in the same spot every time. So Z, we're going to go Y, Z, X. So this is our right angle. That's our right angle in this triangle. And that's our right angle in that triangle. But if you notice, this one starts with Y, Z, X. The next one is W, Y, Z. Well, we really need to start with Y because we started with Y on that one. And Y, there's only one version of that angle in this scenario. So because these are not in the same order, this is not going to be the answer. These here, if you go through these, they're mixed up. The order's wrong. They put the right angle in the middle. They put the right angle at the end. But if you look at C, C should be your answer on this one because they put Z, Y, X. Z, Y, X. There's our right angle at the end. W, Y, Z. W, Y, Z. Right angle at the end in this large triangle. And W, Z, X. They start with W, and they keep the right angle last in every naming of the triangles. And so C would be your answer because it puts everything or keeps everything in order. Okay? Number 13 and 14, pretty simple. Again, these are not hard at all. If we use special right triangles, and we had sine of 45, if you'll remember, a 45, 45, 90 triangle. If you had 1 on the sides, then the square root of 2 was the hypotenuse. So if I took sine of either one of these, it's opposite over the hypotenuse, right? Sine of 45 is opposite over hypotenuse. Now, we don't like the radical in the bottom, so we multiply it times square root of 2, multiply the top times the square root of 2. So that's the square root of 2 on top, and the square root of 2 times the square root of 2 on the bottom is 2. So that would be C. Now the other thing you could do here is you could say, well, okay, I don't remember what the special right triangle is on this one, but what is the sine of 45? Oh, sine of 45 is 0.707106, blah, 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 blah. Okay, which answer down here is the same thing? Oh, well, I'll try square root of 2. Let's see here, square root of 2. Nope, that's not it. That's not the answer I'm looking for. I can try square root of 3 over 2. That's still not it. I can try square root of 2. Oh, let's take that divided by 2. Oh, looky there, square root of 2. And then we divide it by 2. That gives me the same answer. Voila, you've got it. So you could find it by using the calculator, or you could find it by knowing the special right triangles. Same thing on number 14. Sine of 30. We're going to have our 30, 60, 90 triangle. And the sine of the 30 angle, if this was 1, That would be 2. That would be 1 times the square root of 3. And so the sine of 30 is going to be 1 over 2. That's my answer. If I put sine of 30 inside here, thank you for that yawn. I'm so glad you're staying awake with us, Abby Mullen. Not to call you out on the video, for that everybody's going to be watching. But anyway, sine of 30 is half, 0.5. Well, which answer is half? Oh, that one. Okay, let's move on to the next questions. 15. Oh, sayonara. We're not going to work on you. Or 16. But 17 we will work on. So we're skipping 15 and 16, going to 17. Which statements are true about the triangle FGH? All right. Now here's what we're reinforcing. Do you know what the cosine of H is? The cosine of H is adjacent over hypotenuse. It's 36 over 39. The tangent of G is 36 over 15. The cosine of G is 15 over 39. And the sine of G is 36 over 39. Now, you put those fractions in your calculator and see if they equal that decimal. And you'll find out real quick that one does not match. That one does. This one does not match, but that one does. Okay, again, let me just show you. If you put in 36 divided by 15, what do you get? 2.4. So the tangent of G should be 2.4, and it is. If we put those side lengths over each other, we get 2.4. All right? And on this one, sine of, 36 divided by 39 should be 0.9237 and sine G is equal to that decimal form, and so that is the correct answer. Simple enough. Let's go to the last page. We're not doing 18. Exit off again. Number 19. Which expressions are equal to 1? Another gimme question on this test. All right, you just put in the calculator tangent 60 times tangent 30, and you're going to find out it's equal to 1. You're going to put in sine 30 divided by cosine 60 in your calculator. It's equal to 1. You're going to put in cosine 45 divided by sine 45. That's also equal to 1, but when you put that one in there, it does not equal 1. Okay, it's just calculator work. I'm going to put calc beside it. Okay, that's an easy one. Last but not least, number 20. Number 20, I like this problem. We had a couple of these in here. Probably should have left 2 of them in here, right? You're going to say, oh, yeah, Coach, we need another one of those because that's an easy one. But number 20, we're trying to find the value of m to n, or this x value. Okay? That's what we're trying to find, x value. What trigonometric ratios can we use in this triangle to find x? We have this angle right there. That's all, the only angle we have right now. But look here. Doesn't matter what this angle is. We have N and L. So I could say, okay, watch this. I know tangent of 60 or tangent of N is going to be this over that, right? So that involves x. So we can use tangent of N, and it would be 5 times square root of 3 over x. That one would work, right? I know that cosine of N is x over 10. It involves the x side, right? So cosine of N is going to be x over 10. That would give me the x answer. I know sine of L. Sine of L would be opposite over hypotenuse. That'd also be x over 10. Okay? What other ones do I have? Tangent of L. Tangent of L would be x over 5 times the square root of 3. Now the other ones don't help me, right? Sine of N doesn't give me x. Cosine of L doesn't give me x. But those 4 do. Now, do any of these match our answers? Well, sine of N. Does sine of N help us? No. Cosine of N. Does that help us? Yes. And it's x over 10? That's correct. Does tangent L help us? Tangent L is x over 5 times square root of 3. That does work for us. And tangent N, yeah, tangent N helps us. 5 times square root of 3 over x doesn't match. So that's not our answer. Okay? See how we're doing? We're just matching up the relationships with those problems. All right, that should conclude your test review. It is tomorrow. I will send out a remind for everybody. So rather quickly, I will put this on here for the ones that are in class right now. It probably won't help many people that are out there, but we will put it up there for my geometry kids. Do good, study hard. We'll see you guys tomorrow.